We're going to be looking at systems of linear equations in lesson 3.5. We actually have 3 ways to solve a system. In this lesson, we're going to focus on 2 of them. So first, we can solve a system by graphing. What that means is you graph both lines. By the way, a system is 2 or more linear equations put together. So solve by graphing, you graph 2 lines and you want to see if they cross. If your 2 lines cross, then your solution is going to be the ordered pair where they cross. So how many solutions would this first example have? This would have 1 solution. And then the solution is going to be that ordered pair, negative 2, 2. So what is the solution? Negative 2, 2. All right, well, it's possible to graph 2 lines that never cross, like this example. These lines are parallel. So the lines are parallel, which tells us that they will never ever cross, which is why there is no solution. You could also use that symbol that we saw from an earlier chapter. All right, our third possibility is what if you graph a line and then the second line is the exact same line? So a solution, if you remember back in the first example right here, is where your 2 points cross, so it's a point of intersection. Well, these 2 lines share every single point, and lines continue forever in both directions, so every single point on these lines is a solution. So this is one that we would call infinite solutions. All right, so one way we're going to solve is solve by graphing. Just graph the 2 and see where they cross. Our second method that we're going to focus on today is going to be solve by elimination. So we have some steps to follow. This is going to be a good reference as you go through your examples. Elimination means that you eliminate a variable, either the x or the y, or whatever your variables may be. So pick one to eliminate. Then we use multiplication. And this will make sense when we go through an example. Multiply the equations by a number, or sometimes it takes 2 numbers, to have the same positive and negative variables. So for example, you're going to want a negative 2x and a positive 2x. Let's say this is the rest of the equation. Something like that. Then you add the equations together, and the reason why you wanted that positive and negative right there is when you add a positive 2x with a negative 2x, it does eliminate, or they cancel out. Then you're able to solve your equation. Once you get your answer, you plug it back in to get the other answer. So again, this will make more sense with some examples, but hopefully it seems a little familiar since we did do this in Algebra 1. All right, for this chapter, I'm going to do songs from the 90s, so let me know if you know this song and who sings it.
I got a blue and red Adidas bag and a humongous binder. I'm trying my best not to look like a minor niner. When I'm for the football team to prove that I'm a man, I guess I shouldn't tell them that I like Duran Duran. This is me in grade 9, baby. This is me in grade 9. This is me in grade 9, baby. This is me in grade 9. If I had $1 million, if I had $1 million, I'd buy you a house. Well, I would buy you a house. And if I had $1 million, well, if I had $1 million, buy you furniture for your house.
Maybe a nice Chesterfield